Okay guys, so today we're going to look at differentiation. We're still on trigonometric differentiation, right? We not going to be doing anything new today really, but we're just going to be looking at some random examples, right? So this video is just for you to get a feel of all the different ways in which they can bring the question, and so you know what to do when you get a particular question, because all the content necessary, we already did that, right? So that's what we're going to look at today. Okay, so for the first one, we have cos squared x, right? And then for the second one, we have cos x squared. Now, if you notice, they look the same. Well, they look similar, not the same, sorry. They look similar, but they're actually different, right? So this one, the square is only on the x, right? So just the x is being squared. For this one, however, the entire thing is being squared. So you're going to see it written like this, but it can also be written like this here. So it's cos x, all that is squared, right? So if you want, you can rewrite it like that. So in order to work out this, we're going to use the chain rule. But before we even go into the chain rule, let's just kind of recap what the chain rule looks like. So we're going to use the shortcut, right? So I have a paper here, so I'm just going to make up a question really quickly. 3x squared plus 2, right? Say we have this question here and we're going to differentiate it, right? So based on what we know, we would take the 4, put it in the front here, then we get 3x squared plus 2 and reduce this power by 1, so we're going to get 3, and we're going to multiply that by whatever the differential is of inside here. If we differentiate the inside of the brackets, we're going to get 3 2s are 6, so we're going to get 6x, right? We can simplify this. 6x by 4, 6 4s are 24, so that's 24x. We're going to get 3x squared plus 2 to the power 3, right? So this is what we did already, right? This is just kind of like to recap before we actually go into that question that we have above. Okay, so I'm just shifting around stuff a little bit. Okay, so let's actually start this one here. So we're going to do the same thing, right? We're going to take the 2 and we're going to put it to the front, right? So dy dx, sorry about that, right? Dy dx is equal to, take the 2, put it in front. We're going to get cos x, and we decrease this by 1, so we're going to get 1. Good so far, right? And we have to multiply this, by the differential of inside here. If we differentiate cos, we're going to get negative sine x. Alright, so this is all that this can simplify, right? If you want to take out the takeaway and put it in front by the 2 cos x sine x, that's up to you, right? If you wanted, you could have left it like this, right? So that would be good enough. Okay, so we're going now to the next one. This is like exactly what we did before, right? This was the session right before this one, right? So we actually notice it's not the entire thing that is being it's not the entire thing that is being squared, it's only the x, right? So dy dx, if you forget how to do this, just look back in your last video, right? So like for this one now, where the brackets is actually on the expression here and not the entire trig function, right? We would do it a little different, like what we learned before. So what we would do is we would differentiate. Okay, so you could either differentiate first or last, it doesn't matter, but alright, so let's differentiate last in this one, right? So you differentiate the whole thing, cos x squared, so treat x squared like it was just a normal letter we had there, right? Without any power and thing. The differential of cos would have been sine, negative sine, right? And then we need to times by the differential of what is in the bracket. So what is in the bracket is x squared. If we times by the differential of that, it will be 2x, right? And we could simplify that, sine of x squared, right? So like I say, you could do the bracket part first or last, it doesn't matter, you're gonna get the same answer. Just make sure you have all the steps there, right? If you forget how to do this, just look back at your last video We did plenty of those, right? You're going to get the hang of it. Okay, so number 3 is just like number 1, except they actually wrote the 4 on the outside for you, right? If they wanted, they could have put that 4 here, right, and make things a little more complicated. So we're going to work out this now using the shortcut again, right? So dy dx would be, forgive my handwriting please, we put the 4 in front. When we differentiate sine, we're going to get cos. Yes, we're going to get cos. Oh, sorry, I skipped a step. Yeah, for the sorry about that. Alright, so we put the 4 in front, we put back with sine 3x decreases by 1, we're going to get 3, and then we need to times by the differential of the inside the bracket. So the differential of sine is cos. Okay, okay, so I think I was doing this one a little too fast, right? So I'm going to just start it over. You're going to see we're going to get the same thing, right? So if you was writing it down anything, you don't have anything to erase. I just need to do this one a little slower because there's a part of it that I didn't realize that was there, and it's going to get a little more complicated. Nothing too crazy, but right. I think I need to explain this one a little slower. So this is sine of 3x. Alright, so y is equal to sine of 3x to the power 4. Okay, so we're going in again. Sorry about that. Okay, so dy dx would be, you put the 4 in front, right? And then you have this here, sine of 3x, reduces by 1, you're going to get 3. And then we will multiply by the differential of inside here. But this that we have here, if we notice, right, so we have to differentiate now. So let me put a working column. Alright, so the next part is to multiply by the differential of inside here, right? So I'm going to put that in my working column and work it out. So it comes like a little new sum that I have, right? Now before it was as an easy one, so you just work it out and you had no problem. But this now, we have to actually apply, the chain rule to that. Okay, so let's work out this here. Sine of 3x, differential of that. Dy dx would be, okay, so it would be, differential of sine is cos 3x, and then we have to multiply by the differential of this here, right? Which is 3. So we're going to get 3 cos 3x. Right? So here we're going to put 3 cos 3x. Right? So that's why I said that I had to kind of explain it a little slower, because you had to actually use the chain rule twice. Right? Okay, so we can move on now and kind of simplify our stuff. So 4 3s are 12. We could leave this sine 3x here and cos 3x, and that's the final answer. Okay, so this one now, this is question 4. This one is actually a bigger question, right? So you don't have anything to be scared about with this question. Okay, so notice it is something here. We have something being times by something here, right? So we have a product. Remember we did the product rule, that was a good while ago, right? So I'm going to write down the product rule on top here just in case anybody forget. So if we have two things multiplying, it would be v du dx plus u dv dx. Right, so we're going to let u equal to sine x, right, and we're going to let v equal to cos 3x squared. Now you notice that squared is only on this here, right? It's not on the entire cos, right? So we know how to deal with that. Okay, so du dx would be the differential of sine x is cos x, nothing too crazy or anything there. Then we have v, we have to differentiate v. So dv dx, 'x would be differential of, okay, so we have this here, right? So it would be differential of cos x is sine x, right? So it's sine 3x squared. We had to times this now by this. When we differentiate this, what we're going to get, right? So 3 2s are 6x to the power 1, right? I'm just going to simplify that one time, right? So what I'm going to do is I'm going to put the 6x in front, sine 3x squared. Right, so nothing too crazy. Then I'm going to apply my chain rule. So dy dx is equal to v. V is this here, cos 3x squared. Du dx is cos x. Right? So I put in my dots to represent times in, right? U is sine x. dv dx is this here. So I put in my dot again. 6x sine 3x squared, and that's it. Right, so that's it there. You're done. So basically it's everything that we learned, but they kind of like come in all together, right? CXC might not bring one like this, but you need to know it in event they do bring it, because Trings is differentiating trigonometric function, sine and cos is on the syllabus, and product rule and quotient rule is on the syllabus, right? So you don't know how they would actually bring it, so it's good to actually know how to work out a question like this in case you get it. This one wasn't too bad. You just, you need to take your time, break it down, and you'll get through there. So these are like how the questions would come. I'll send you guys some questions to actually try.